Okay, let's have a look at the real world problem. The grocery store, which is far from your house, sells a pack of 10 kg rice at a lower price, lower price than the one closer to your house. Is it worth the drive for the cheaper deal? Okay. So you have to identify the I, the big I, identify and defining the problems. So you know that the price, you must know the price of a pack of 10 kg rice and the cost of petrol because you use your car to reach the stores, yeah. And then you have to determine the distance, yeah, of course the distance from the two stores from your house. And if it's really too far, like 20 kilometer from your house, I am sure it's not worth it, yeah. And you have to find information about the price in store A and store B, the 10 kg, and then the distance, we said just now, the distance, the current petrol price, and the car petrol consumption rate, and so on. All that you have to consider. Okay, what the second one is? Okay, you have to make assumption, yeah. I am, you want to make assumption. So the route between the house, store A and store B, is perfectly a straight line. No turning here and there. So you drive car to the stores, purchasing the same number and brand, of rice lah. The same brand, you cannot use different brand from store A and store B. Okay, so let's say this is your house, yeah, this is your house, and then use your car. This is a store A with the same brand, yeah, and this is store B. That's why, yeah, you have to make assumption it is a straight line. It's a straight line. Okay, next is you have to identify the variables. What are the variables? This is very important. First, of course, that variables are the things that change. So what will change is, of course, the distance will change, yeah, between store A and store B. There is a difference. And then the price of store A and store B will be different. Yeah, this one, P1, P2. Okay, the petrol consumption rate of the car in kilometer per liter also will see. The number of packs, yeah, how many packs of 10 kg rice that you will purchase, this also will change. The current petrol price, yeah, RM per liter, you have to consider. The difference of price purchasing, different price, yeah, of course. And the different cost of petrol in RM for driving to store B as compared to store T. You will find the difference. Now you will applying mathematics. The third one is M, mathematics, to solve problems. Yeah, applying mathematics to solve problems. So let's say you got this store, the price of the 10 kg rice is this one, store A and B. So let's say this one also you have to fix. You want to buy 2 packs only. So you calculate times 2, times 2. This is the price you pay. So this is what you save. Yeah, you minus lah. This is what you save. And then let's say the distance is 6 kilometer. between store A and store B. Yeah, the petrol consumption rate of the car is this one. You already calculated. The current petrol is this one. You got the information already. So petrol needed for 10 kilometer route is use this formula and you get this one. You'll use 0.341 liter. Yeah, if this is your house, this is the store A, this is the store B. So you count this distance. You use 0.341 liter. You cannot calculate from here because you want it just from here. This is the extra petrol that you will use, and you'll use, and you have to pay. You times with the rate 2.08, and you have to times 2 because 2 ways. Yeah, 2 ways. You have to 2 ways go and back. Therefore, you save the price only this one. So you minus this is you save from buying the 10 kg rice. You minus with the petrol that you use. So this is what you save, 2 ringgit and 50 cents when you purchase 2 packs of rice at store B. Okay, so do you think it's worth the 2 ringgit 50 cents? So you will verify, you will verify and interpret the solution. We'll see whether it's worth or not. So what you do, the resulting mathematical model is as follow. Your S, you save, you make a formula like this. Yeah, the price of you find the difference of the price, store A and store B. You times with the number of packs of rice, and then this is the T is your difference of the cost petrol. Yeah, so this one also we calculated just now. So if your S is the price, yeah, the difference of price. T is the difference of petrol. You use. So if your S, your price, S is more than your petrol use, then it is sensible to drive to store B to purchase rice and save more money. But if you get less, it should not drive to store B to purchase the rice. Okay, for example, you calculate this one. This is the store A minus store B, you times 2, you get this one. And then the petrol, it's 6 kilometer over the 17.6 is petrol consumption. Yeah, this one times the cost of petrol, then you get this one. 3.92 is more than 1.42. So it's sensible to drive to store B. But if you calculate, it is less, so better not. You actually lose money. Okay, if the variable remain the same, how far can store B is located so that it is an optimum choice? This is another one. Further exploration. You can use this model, this one. Yeah. And this time, you keep the distance. You keep the distance S is the distance between store A and store B. This is what you want to know. How far can store B located? So this is your S. So if you solve these inequalities, your S must be less than 16.6 kilometer. If it is more, then it's not sensible for you to drive to store B. If it is less, yes, okay, you can go to store B to purchase. That's what I said just now. If the store B and store A is more than 20 kilometer, it's not worth it. Too far. Of course, the oil consumption, petrol consumption will be more. Yeah. So, but you have to check also, number 2, what is the maximum price of pack 10 kg of store B that will attract a person? Yeah. So it must be, you use this model, yeah, use this model. This time you don't you let this as a variable, this P2, yeah, price for store B. This one still the same, okay, and you get P2, it will be must be less than 25 ringgit and 24 cents. Must be less than this. So it's worth the trip. If it is more, no. Even though it's still cheaper than store A. You know, store A is how much? Store is 25.95. So store B, you must get the price at least. Minimum is this one. Must be less than this. Then it is worth the trip. So therefore, the above mathematical model allows us to not to only answer the question of is it worth it for the given situation, but also allows us to determine other factors that support or oppose the decision, yeah, for you to try further to purchase the rice. So now we can reflect the model and question that arise as follows. Can we have a negative answer? Are our assumption relevant? Does this model follow the assumption met? What are the assumptions if our assumption is wrong? What are the scenario changes a little? And then, is the model still valid when we increase or decrease the input variable? All this we have to consider. So reflection enables us to think of the needs to refine the mathematical model. So you can see here, if it is not a straight line, how does the impact of our model? If the store is not a straight line, have to go here, turn right, and then you reach. And then you have to report your findings, the last R. So you have to use symbols, diagrams. The symbols will depict the whole modeling process until it leads to results. You see, you use symbols just now. Okay, and then what is important is that the model identifies those strengths and weaknesses in this report. For example, the value of person's time is not considered. Yeah, is it worth driving 12 kilometers for someone to save 2 ringgit 50? According to this model, saving 5 cents is considered worthwhile. Remember that. Even though you save 5 cents, it's worthwhile. You collect it every day, it'll become a big number. Yeah. The model did not account any environmental consideration. Yeah. what happened if that something happened to you during the journey, and then this model did not account for environmental efforts such as reduce the carbon emission. You use more petrol, that means more carbon emission from your car. This one also you have to refine it. Yeah, we have seen how mathematical models process works by one example as shown above. So we should emphasize that we cannot use this example as a template to solve other problems. Only this problem. In solving problems through mathematical modeling, every individual or every group has different ideas, skills, and perception. So open-ended questions such as these may even generate completely different mathematical models, which are valid yet result in different answers. Okay?